Everyone, a very good morning. Shall we begin the session? Yes, today's topic is chapter number 8, that is exceptional control flow. What are the various exceptional control flow that is available, why we use exceptional control flow, and what are the various benefits, drawback that is available in the exceptional control flow. Yeah, in this chapter we study about the try block, catch block. Alright, okay. So the first part is exceptions, then there is the processes, then there is system call, error finding or error handling, then process control, then after that there is the signals, then non-local jumps or the loop that is available over here, then tools for manipulating that process, then summary, bibliographic notes, homework problems, then solution to the practice problem, whatever the problem that we are acquiring, whatever the scenario that we are using, so that is used with the practice problem. So exceptions, processes, system call, process control, signal, non-local jump, tools for manipulating the process. Now, from the time you first apply power to the processor until the time you shut it, that is used with the control transfer, that is used with the flow of control flow of the processor, that is accepted, that is abrupted changes as exceptional control flow, that is ECF. Now, as a programmer, there are many reasons which it is called to understand the ECF. Understanding the ECF helps to maintain or helps to understand important system concept, that is the basic mechanisms that operating system uses to implement the input-output processes and the virtual memory. And before you can really understand these important ideas, you need to understand the ECF. That will help to understand how application interacts with the operating system, how it is used with the operating system by using a ECF known as a trap or the system code. For example, when we write the data to the disk, read the memory to the disk, that is also available with the ECF, that is used with the network, internet, that is all accomplished by application programs invoking the system calls. And understanding the basic system call mechanism will help you understand how these services are applied to the application. How these services in the sense, how these efforts, how these operating system will help to proceed with the application. Then understanding the ECF also ensures or also used with a new application program that provides application programs with a powerful ECF, with a powerful mechanism that used for the new processes, for the waiting for the process to terminate, notifying the other processes of the exceptional events in the system, and also direct and response to these events. Now, whenever you apply the ECF mechanism, then you can use to write the interstrict program, such as the Unix, such as the shells, whatever the shell, whatever the program that we are using. Now, next is understanding the ECF will help you understand the concurrency. So, whenever we are using the concurrency module, that is also used with the concurrent concept. So, ECF is a basic understanding for implementing the concurrency in the computer system. Concurrency in the sense same and same modules and same data or the fetches are used in one another, that is used in the computer system. And whenever we are using the exception that interrupts, so there is an exception that interrupts the execution of the application program, mechanism, process, and the threads. Now, what is a thread? That is a lightweight process whose execution overlap in the time, and a signal handler that interrupts the execution of an application program. These are the example of the concurrency in the actions. Then next is understanding the ECF that will help you understand how the software exception works. How the software exception works, that is done by the various languages such as the C++, Java, that provides a mechanism where the try, to, catch, and the throw statement. So there are three statements, or we can say the main statement that is available. Now these are the main statement that is available. So these are the try, catch, and the throw statement. And the software exceptions also allows a program to make the non-local loop. Now, what is a non-local loop that is available that does not violate the call return stack principle discipline that is available in response to the error condition? And then when we use the non-local jump that are a form of the application level ECF that is provided in the C language by using the two functions, one is the set jump function, one is the long jump function. Now, up to this point, we have studied how the application interact with the hardware. Next is how the hardware interact with the operating system. Yes, one is application interact with the hardware. Next one is the hardware interact with the operating system, that is used with the ECF that exists at all levels of the computer system, that starts with the exception that lies at the intersection of the hardware, software, operating system, that is used with the exception entry point into the operating system. Now, Comes to the first point, that is exceptions. So this is an abrupt change in the control flow in response to some change in the processor state. So whenever we are using the control flow that is in response to the change in the processor state, that shows the basic idea of the current transaction, instruction, I current. When there is a significant change in the processor state that occurs, that state is encoded in various bits, signals inside the processor, and the change state is also known as the event. So whenever we are talking about the event, that is for the exception. And the event might be directly used, might be directly one of the related to the execution of the current instruction. For example, when we talk about the virtual memory, page fault occurs, so there is an arithmetic overflow occurs for an instruction that attempts to divide by 0. In other words, on the other hand, the event might be unrelated to the execution of the current instruction. For example, a system timer goes off or an input-output request completes. In any case, in any of the case when the processor does not relay that detects that the event has occurred, it makes an indirect procedure call through a jump table known as the exception table to an operating system subroutine, that is exception handler, that is specifically designed to process this particular kind of event. This particular kind of event in the sense, whatever the kind of event, whatever the procedure that we are taking out, so that is used to process the things, that is used to process each and everything that is available with the event. Now, in any of the case, when the event handler occurs, there is an application program, iCurrent, iNext, exceptional, then exceptional return, optional, then there is exception processing. In any case, whenever there is a processor that detects that the event has occurred, and the handler returns the control to the current instruction, then the instruction that is available over here, that when the event has occurred, and the event handler returns to the line next. So whenever we are using the instruction, that would be executed to the next, that is executed to the next part that is available within the execution state, that is available within the exceptional case. Now, hardware versus software exception. What are the various hardware exceptions? What are the various software exceptions? So first is the exceptional handling. So exceptions can be difficult to understand because handling it is very difficult. That involves various or close cooperation between the hardware and the software. That is very easy to get confused with the hardware about which content will be used, which criteria will be used, which hardware software will be used. And each type of possible exception in a system is assigned a unique non-negative integer exception number, and some of these numbers are assigned by the designers of the processor. Whatever the designer we are using, that is designed by this one, that is known as a kernel, that is a memory resident part of the operating system. That is also known as exceptional table or the exceptional table based register, that is used to generate the addresses, generate the exception handlers. Now, whenever we are using the exception, there is an exception table based register that is used with a CPU register known as this one, and the exception table to form the address of the appropriate exceptional handler. In such a cases, the processor detects that an event has occurred and determines the corresponding exception method K. Whenever we are using K, the processor then triggers the exception by making an indirect procedure call through entry K of the exception table and the corresponding handler, and in this figure that shows how the processor uses the exception table to form the address of the appropriate exception handler. And exception number is also indexed to the exception table where the base register starting address is contained in a CPU known as the exception table base register. So whenever the processor pushes a return address to the stack before branching to the handler, that depends on the class of the exception, that depends on the return address, that is either the current instruction in which it is using or the next instruction that will be executed after the current instruction. Then processor also pushes some address or additional processor state onto the stack that will be necessary to restart the interrupted program. And if the control is being transferred from a user program to the kernel, that is pushed to the kernel stack rather than to the user's program. Then exception handlers runs in the kernel mode. That means they have complete access to all computer or the system resources. And once the hardware triggers the exception, the rest of the work is done in software by the exception handler. And after the handler has processed the event, that optionally returns to the interrupted program by executing a special return from interrupt instruction that will go for the appropriate state back to the processor control and data registers. That restores the state to the user mode. If one of the exception interrupted a user program, then returns to the uninterrupted exception of the program. Now next is what are the various classes of the exception that is available. First is there are multiple classes we can say, and that is divided into 4 classes. Yes, that is interrupts, that is something is occurred in between. Then trap, that means uh, focus on something. Then faults, then abort. So these are the 4 classes in which we can divide the exceptions. Now interrupts occurs asynchronously as a result of the signals from input-output devices that are external to the process. Yes, that is available with the interrupt that is used are asynchronous in the sense they are not concerned in the or they are not caused in the execution of a particular instruction, and these are also used for the hardware interrupt that is known as the interrupt handler. This figure shows what are the various interrupts or the classes of the interrupts. So first is the interrupt, that is a signal from the input-output device. Then synchronous or the asynchronous, this is asynchronous, then always returns to the next instruction. Then trap, that is intentional exception, that is also synchronous, always return to the next exception. Then fault, that is potentially recoverable error, that is also synchronous, that might return to the current exception. Then non-recoverable error, that is synchronous, that is never returns. Then traps on the system call, that are the intentional exception that results as a process of the taking out whatever the data we are using, whatever the scenario we are using for the data, that is used with the fork, that is used with the read, that is used with the executable files. Next is the traps and the system call, that are the intentional exception that is available that occurs as a result of executing an instruction. Like interrupt handler, trap also handler or trap handler also returns the control to the next instruction. And whatever the most important usage, whatever the most important trap that is used to provide a procedure like interface between the user program and the kernel through a system call or known as a system call. And user programs often needs to request the service from the kernel, such as reading a file, creating a new process, loading a new program, or terminating the new or the current process. That is used with the read, for executable, or terminating the current process, that is exit. And to allow the control access to such kernel services, processor also provides a special system call, that is system call instruction to such kernel services that provides the processor that provides the system call, that instruction that user program can execute when they want to request the service. And in this, we are also summarizing the process for a system call. From a programmer perspective, a system call is identical to the process. A system call is identical to the values. So there is application makes a system call, then control passes to the handler, then handler returns to the instruction following the system call, then trap handler returns. Next is the current instruction causes a fault, then control passes to the handler, then fault handler runs. That is used with the function call, that is used with the implementation, that are quite different. And the regular functions runs in the user mode, which restricts the types of the instruction they can execute. Whatever the stack, whatever the calling function, whatever the return type, whatever the kernel mode that is executed instruction, and also access the system or the stack defined in the kernel. The next is the fault that results from the error condition that a handler might be able to correct, and when a fault occurs, the processor transfers the control to the fault handler, and if the handler is able to correct the error condition, it returns the control to the faulting instruction, thereby re-executing it. That is known as a fault. Fault means any we can say the exception or any program that causes the fault. And a classical example of a fault is that a page fault exception that occurs when an instruction reference or instruction refer a virtual address whose corresponding physical page is not resident in the memory and must therefore be retrieved from the disk. And as we will see in the page fault handler that loads the appropriate page from the disk, returns a control to the instruction that also causes the fault. And whenever the instruction executes again, the appropriate physical page is resident in the memory, and the instruction is able to run to completion without any faulting, without any failure. Then abort that results from the unrecoverable fatal error, typically hardware error such as a parity error that occurs when DRAM or the SRAM bits are corrupted. Yes, abort handler never returns control to the application program that is used for the handler that returns a control to an abort routine that terminates the application program. Abort means terminating the application program, whatever the application program we are running out. The next is exceptions in the Linux IA32 system. That is used with the IA32 system. There are up to 256 different exception types, and the numbers in the range from 0 to 31 also correspond to the exception that is defined by the Intel architect, and therefore that is identical for any IA32 systems. And whatever the number that is in the range from the system that correspond from 32 to 55 correspond to interrupt and trap that are defined by the operating system. Now this is the exception number, this is the description, this is the exception class. 0 divide error fault, 13 general protection fault, then page fault, 18 abort, 32 and 27 OS defined function interrupter call. Now this is a Linux fault and abort, that is the same Linux system call, but means whatever the scenario that we are using, that is the same in this one. Now next is processes that I'm going to take within the next class, that is the tomorrow's class. Right. So if there is any doubts, yes, any doubts, any confusion, anything that you want to ask. Today we are finished with the task, whatever the task, exceptions, what are the various types of exceptions. And in the tomorrow's class, I'm going to take the process. What is the process? That is a thread by thread process. That is an instance of a program. We can say a part of the program in the execution, that is known as a process. So whenever a program in execution takes place, that is known as a process. So a process is a program in execution that takes the executable object file, that takes the file to the shell, that makes the program correctly. This states that includes the program code and the data stored in the memory, its track, its content of a general purpose registers. Yes, that includes the program counter also, everything. This we will discuss in the next class, that's in the tomorrow's class. Alright, any doubts? Okay, bye-bye everyone. Yeah, one thing more, that any doubts, anyone in the assignments, anything that you want to add, and please submit the assignments on that time. Please, so that we can finish this course on the time as well as issue the certificates to you. So please submit the assignments on the time. It's my humble request again, and pass this message to the other students also. Alright. Okay. Yes, assignments is very crucial. Yes, I agree. Because that makes a give, or that